My name is Ruslan. Welcome to my session. Happy to see so many of you made it, despite all of the temptations. I'm in sessions, but to each his own. Hashtag LinkRest. If you have questions, please feel free to Twitter. I will answer those questions as much as I can, and also there are a couple of my friends who work on LinkRest project who will also pitch in. They're pretty sharp, so it's well worth to post those questions on Twitter. I feel pretty lucky to be here today because I had a family situation that I got a lot of help from good friends, and it's just great to be here. Almost canceled, but it worked out. So good to have good friends. Let's get started. So let's talk about APIs. Roy Fielding, author of the REST architecture, he would not be happy with me today, but he's not here, so let's talk about RESTful APIs. And the problem with APIs in general is that you have to maintain them, and that's a lot of effort. We need to have people tend to the changing sort of circumstance of the system, of the overall system, and make adjustments to APIs. And I kind of call those people API attendants. So someone architects or designs the API, and then you have to constantly maintain and make adjustments. And that's sort of like being an elevator attendant. We can push buttons. We don't really need them. And just generally having to go through this refactoring cycle over and over. It's not just, it doesn't just add overhead. It puts this question, is it worth it, in front of every improvement opportunity. And that's a lot of opportunity cost. And my personal peeve about this is just being in this mental, facing this mental math every time you have to make an improvement. Is it worth it? You kind of end up censoring yourself against some of good ideas that you could be using to improve an application, but you just don't because of the censoring mantra that you go through, and that's just not, and all of that is just because of timing. You're thinking, okay, this is going to take too long, I'm not going to do it, and at the end of the time, at the end of the day, it's just not a good place to keep yourself happy. That's just not how you keep enthusiastic about a project. So, and the solution is much like with elevator attendants. Skip the middleman. We don't need API attendants. And it's a win-win. I haven't seen anyone who likes to tend to APIs. You design it once and you want to stay with what you have. And LinkRest is our attempt at removing API attendant from the development cycle. So what is LinkRest? It's a protocol. It's a protocol that is fully compatible with XJS REST Proxy. So it is also an implementation of this protocol. It is extensible, and we have made some extensions that are gonna, you will see, are pretty helpful. There's some magic there. At the bottom of LinkRest stack is your data store. So whatever it is that you use today is probably going to work. On top of that is the ORM layer, which is what kind of abstracts the records and record sets into object graph. That object graph is made available to the client by LinkRest, via LinkRest API and protocol. And again, the protocol is fully compatible with XJS. It just talks to it natively. There is no accommodation that needs to be made on LinkJS side, on XJS side to use this protocol. What is LinkRest not? It is not a monolithic application framework like Spring or Rails. It is not a complete application server. So you will need to use something like Jetty or Tomcat or something else to actually run the application sort of side of it. This is a API framework. Which is a good thing because it's not a replacement for any of your existing frameworks. It will just work in parallel, and again, that's a good thing. So you can easily shuttle it in for a pilot project, test it out, see if it works, even in a specific scenario. It doesn't have to cover all of your needs on day one. Couple of factoids. LinkRest is a project commissioned and open sourced by NHL under Apache license. It was conceived specifically to be the server-side counterpart to XJS, which probably explains a lot of XJS specificity. It was first released in May of 2014. It's hosted on GitHub. Current version is 2.2, and we've built a ton of apps with it already. Your turn now. Compatible with pretty much any modern database engine, both relational and NoSQL. It does support an alternate ORMs. Currently, it supports Cayenne. Comes out with support for Cayenne. It also supports an ORM-free mode where you can basically create a POJO structure and just stream it out with LinkRest, which is useful for scenarios where you need to communicate a transient structure of data from the server to the client, like a session or maybe a status, something like that. In basic use, LinkRest again provides full support for XJS. It supports full suite of create, read, update, delete operations. Batch actions is supported. It's a parameter. Not everyone knows about it, but it's a parameter you can give to REST Proxy, and it will send updates. You can stage updates and then send them in one batch. I'll show that how that happens in a bit. Obviously, paging, sorting, autocomplete, which is something that a combo box will do for you. Filtering, including support for the operator and disabled options. This is very handy for using with bindings. So I'm going to run through a couple of examples, and I'm going to use a database with this schema. So let me just explain what's going on, just kind of set up geography here for you. So there's 5 tables. Being NHL has to be about hockey, so bear with me. 3 entities, player, game, and team. 4 relationships between game to the home and to the visiting team, and between game and player, the visiting roster and the home roster. This gives us 4 different kinds of relationships to work with and to sort of demo with. So to implement this API to this schema, we're gonna need 3 endpoints, 3 REST resources. One for player, called player resource, one for game resource, and the team resource. Let's take a look as an example at the team resource. And for the love of me, I cannot make code look good in Keynote, so I'm gonna flip to IntelliJ. So let's see if you can see this at all. Can you see this at all? Let me make it bigger. Can you see this from the back? Okay. So an important point to make here is, except for the actual calls to LinkRest, none of this is LinkRest specific. This is a vanilla JAX-RS application. So pretty much any compatible or Servlet 3.0 compatible server would probably work with this. So we know it works with Jetty, works with Tomcat. I'm sure any other compatible system will work. In this particular example, there's 3 methods to return a collection of entities of type team. That's this one. That's commonly referred to as a list method. So this, and you can see that all that happens here is we pass into the LinkRest command chain the type of the entity and the config, which is something that is injected from the container. So this is just the context of the REST request, or HTTP request, I should say. And we just feed additional parameters or additional commands into the command chain to LinkRest to add additional options that we might need for this particular method. And this one is very simple. The URI info is basically the context of things that we will be sending into this request, and you'll see them later in a demo. And LinkRest takes care of everything in terms of parsing all of these commands, paging, sorting, filtering, anything else. And then the last command is what you would normally do in just to end a command chain. Just executes the command, and what comes back is the data response of teams, and that is just a structure that implements the success data array of data items and the total to tell the client how many records in total at this endpoint. The second method is the method that returns a single item of or single instance of entity of type team, and the only thing that we have extra here is just we're passing in the ID of the entity that we want to return. And then the method for updating, and this is updates a single or a batch of entities. So again, that's the batch actions option. So let's take a look at what this looks like from XJS side. So this is a perfectly conventional grid that lists 3 basically columns. This is just for effect, but the 3 columns are the abbreviated name, common name, and full name. As you can see, the grid is fully functional. It refreshes, it sorts, it pages, it does all things that any normal XJS grid you would expect to be able to do. Again, there's no special accommodation to LinkRest in this code whatsoever. So let's look at the code behind this. This is definitely not visible. So let's see. So this is the implementation of this tab. So we have the panel that's kind of the member of the top panel. This is the grid, and this is the view model of this sort of segment of code. So the only kind of a quirky thing here is that there's a toggle that switches on and off autosync. Autosync is what tells the store that it needs to send updates immediately. So for example, if I'm gonna make an update, well, let me turn it on. So if I make an update, it will go to the server immediately. If I autosync off, then I can actually stage some of these updates and then sync them all at once. And let's see what that looks like in terms of network traffic. So this was the last refresh that we got. right? So what XJS sends to the server is the page number. I guess we were on the page 2. Start would be which record to start with. Limit is how many. And in this particular case, obviously, we've set page size to 10, just so that I have an opportunity to page this for you. Then there was one update that went, just a single update, and this is the payload of the update. It went to the to this location, to this endpoint, and that mapped to this method here, right? So pretty straightforward. This is not rocket science necessarily, but I just wanted to show you the details of this interaction. Now with the auto sync on or off rather, the second request included 3 updates, and the interesting thing here, obviously, is you sending in one request in one put updates to 3 entities, 3 records. So that's and again, LinkRest handles that all automatically and on your behalf easily. So let me go to the next slide. So advanced function, or rather, some of the features of LinkRest easier to access with this thing we LinkRest Proxy. We haven't really properly released it, but it's part of the demo, so you can just sort of pirate it off of it and use it under Apache license. Feel free. Blessing and curse of this project is there's really very little accommodation that needs to be done on JavaScript side. So there's really not much to release. So this class is like, you know, we didn't feel that it was worth releasing. Let me show it to you. Here it is. So this is all of it. So not a huge thing, but welcome to take it, and it just makes some things much easier. Now, all extensions of LinkRest protocol are about giving the client, the XJS client, the ability to query the data and then shape what comes back directly from the client. And it's done securely within constraints, which I'm going to talk about that a little bit later, but it gives you a lot of power on the client side. And so the first feature to talk about here is these includes, the include directive. So let me show you what that how that works. This is what a typical endpoint would return. In this case, the team, and I put a limit of 2 just to make things easier visible. Can you still see this? Probably not. So let's, is this better? So in this case, by default, if you don't specify includes, LinkRest will return entities with all of their resident attributes included. So, so let's look at a game, for example. So the game endpoint will return, again, resident properties of game date, well, ID, game date, game number, etc. It does not include foreign objects, so it does not include home team or visiting team. And to do that, you need to use include. So, and the way you do that is just like that. You specify that you will you wish to include the visiting team and the home team, and just run the call. And what you get is an object for the home team and for the visiting team. Does that make sense? Okay. How would you use this? For an example, if we were already had this API available to us, but we're working on a website, and maybe we want to put up a game ticker at the top of the page. But we kind of want to be economical. We don't want to load everything because in real life these tables are much larger and you would get a lot of data that you don't really need and just use up the bandwidth. Instead, what you can do is just include only things that you need. In this case, maybe you want to get the game date for the ticker and the team names, and that's it. And maybe you don't even need ID and limit, and just send request, and you get. Forgive me. Let me take out this confusing weather because we're going to talk about that in a second. So, and you get only as much as you need to get. So that's actually a pretty handy thing to be able to do. Another example, if we want to request, and you recall the game has a relationship to team, but also team has a reverse relationship to game. So a team knows its home and visiting games. So if you include the visiting games and the home games, then you would get for any given team, you get the collection of home teams and visiting teams. So in real life, maybe it will look like this. So let me give you an example that's maybe slightly more realistic. So if we have a list of games and want to see who played on these games, you would can you see that? What we requested actually right now is let's see. Is the from the game resource, we asked for visiting team, home team, and we requested also the visiting roster and the home roster. And that got included in the output. So if you look at any given game, you see that there's a home roster and visiting roster here. And we can, without having to make an extra trip to the server, we can see them right here. These, again, because this is fully sort of native to XJS, these inflate correctly associations. So in this particular case, the relationship to rosters to the players is specified as a has many relationship, and this just all works again natively to XJS. One way to use this would be to kind of this is a crude way of showing how a team roster might be managed. So you have a team and you want to add someone to the team. Maybe I like Ovechkin. And it's just simple as that. So what happened right now is XJS sent to LinkRest an update with a list of the newly selected players for this game, and that's it. I mean, it's pretty straightforward as far as I can tell. So these are includes. Occasionally, you want to, because when you request, like in this example, you request to include visiting games, for example, they just come back as a collection, unsorted, unfiltered, If you do want to apply some discretion in terms of what comes back on what order, then you would, instead of a string, you would use an object and you would specify additional options as far as what should come back. And a good example would be, so if we requesting visiting games for a team, we would request that the games would be sorted by game date in descending order, and that's what we would get. So this is exactly what we got. So these are games sorted by game date in reverse order. So in the same way, you can also apply a filter. A real-life scenario might be something like maybe you're working on a customer list and you have a drop-down and you did a set up an include with just the customer name, and so far that's enough. And then you realize that you would like to be able to also include the last date and maybe value of the last order that they made. Well, you can actually include that if that's available in your schema. You can include that and make that data available to the list, and that just gives your user more context to make better decisions. So let's look at filters and sorters. So you've seen sorters already. Let's play with filters a little bit. And again, XJS gives us a very robust functionality in terms of filtering. And LinkRest plays very nicely with that, just kind of accepts what XJS would do. Let me give you an example. So this would be, so this is a list of players, and maybe I want to search for Ovechkin. Where did he go? Something broke. Well, let's try a different filter. So let's try this one. Suppose I want to see all home games of, let's say, Chicago. So what happens right now is this. This is a ViewModel. This is the store that populates that grid. So this grid is populated from this store. This store has 3 filters pre-configured. And until selections are made in those filtering drop-downs, these filters are disabled. There's actually an option in filters you can say disable on blank, but I just wanted to keep this explicit. So these filters were disabled until I selected a value in this drop-down. And because that value was selected, so it's not blank, it went from disabled to enabled, and the filter started selecting only games that match the selected team ID. And this is what went to the server. I don't know if you can see that, but can you see this? So the home team here filter is no longer disabled, and the filter value is 16, and the property that we filtering against is home team, and that's exactly what we get, filtered by we can also search by, let's just another example, we can query by player that plays on any given team. So for example, display plate on these teams here. So, and you can find his name right here. So there are many ways you can query the data. Again, this is all coming from the client, and you have full control of what you get. Cayenne expression. Occasionally, filtering is just not enough. So particularly when you need to OR a couple of expressions. So if, and let me show you an example of a Cayenne expression is something that's similar to a where clause in a SQL select. It's compatible with JPA expression language, and let's see. Suppose I want to only list in the players store players that are above, or actually below the age of date of birth of January 1, 1992. But I don't want to exclude older goalies. So this would be how we would write it, and you would, this OR is what prevents me from using filtering. But this is what you would specify. And this is the request that went out. And you can see this is the Cayenne expression. And some of you might immediately ask, what about SQL injection? Like, no, these requests go through Cayenne expression parser, and they're perfectly safe. Cayenne expressions work in parallel with filters, so these are not mutually exclusive. In fact, you can, and it's very handy to be able to use both. Next. Entity property. So occasionally you need to be able to inject an external data point that is not available in your data. Maybe you, like in this example, the example I'd like to show you, we're injecting weather information into the game output, and maybe that data comes from an external service. So that's a helpful. So in order to do that, you need to use this entity property. And the way that looks like is this. The game resource. The class that implements this injecting can be a private class, is this. LinkRest will instantiate an instance of this class as it runs. Will apply it to every record that it's about to serialize, and ultimately you will get that data out. So let me return back these guys that I rammed out just earlier. And let's see. And so now this data point, in fact, an object, is injected into the output. Not something that you would use frequently, but when you need it, you kind of need it. Pojo encoding, I'm going to demo because it's kind of a trivial example. MapBy is a quirky concept, and it takes a while to explain, but the point of it is to basically pivot your data and make it available as a matrix. So if you have maybe a collection of games and you want to see how they distribute by date, you can map by date or map by maybe opposing a team's name, and then that will give you a map of these games arranged by that key. And it's very useful, but maybe I'm not going to go into that right now too much because it's just going to be difficult. But it is included in the example. So in the demo, so you can actually look at it later. Multi-source. Also something I did not include in the demo, but you need to know that it exists. It's a way for LinkRest to basically request data and join it from two separate data sources. So maybe you have two divisions and you happen to need to include maybe people from both or products from both into the same output. That would be the way to do it. Idempotent updates and more importantly creates. So idempotency is a property of a method where it can execute the same request twice without any additional side effects. So an update would be idempotent. A create usually isn't. So if you execute twice, a create probably will create two records. So there's a facility in LinkRest that will allow you to create, to set up a create or post method to be idempotent. So for that, there's it is an example. So there's a mapper class that will that basically tells you, okay, these are two objects, and it can tell you that they're identical, they're the same object, and that's what kind of makes it happen. And feature-wise, the last thing I would like to mention is LinkRest knows a lot about the data, your database, your data. It knows from what it can interrogate of the database. It knows what it can interrogate from interrogating the ORM layer. It knows your data types. It knows its relationships. So that metadata is available through that metadata service. And the way we've used it to some extent, we kind of need to evolve this more. And I'm hoping that you guys will maybe share some feedback on what you would like to do with it. Right now, what we've done so far is, so maybe it's easy to show from here. So this is a component that knows about the, basically, ultimately, it knows about the endpoints where the metadata lives. It can retrieve that data and on the fly construct a grid, and knowing what the data types are, in fact, what the relationships are, and knowing that maybe a visiting team is a selection of entities of type team, it can actually construct a dropdown and works extremely well for like configuring type tables. So a lot of the time you have tables that need to be maintained and you don't want to spend time actually building them, but you need to have them. This is a great solution. So I see this as a first step in using this metadata. I would like to evolve that more and just looking for good ideas. So in this case, for example, game, home team, visiting team, again, we know that the home team is of type team, and we can get the drop-down. This is all generated on the fly and automatically, and because it knows that the team entities are available at the team endpoint, it generated on the fly a store and wired it to this drop-down. So. Very quickly, let's talk about security. So restricting access to a resource based on the identity of the subject, of the user, is what we call authorization, and LinkRest is focused on what it does. It doesn't trespass outside of that focus. It's not going to help you. I'm going to mention this project, and whether you end up using it or not, it's my personal sort of belief that understanding permissioning math of this product, of Shiro, is going to make you a better developer. So if you want to check it out, that's probably a good idea. Now, restricting access to resources, irrespective of the subject, of the user, is constraining, and LinkRest does help with that. First thing to do is just under-implement methods that you don't need. In the example of the team resource, we did not implement create or delete because that's not something that you routinely do, and this app would not be expected to be able to delete or create new teams, and as such, those methods were not implemented. So this is a simple but effective way of constraining an API. ORM graph, if you let it be free-for-all. It will cover a lot of connectivity, and you can kind of navigate through the graph to weird places. Trimming it down is a good idea, and obviously common sense. Implementing fewer relationships in the API, or exposing fewer relationships is probably better to start, and then if you need to add more, you can do that. There are two special annotations. These are annotations on entity classes on the model. Spelling out a client readable for an entity would tell it which attributes should be visible to the API, and the remaining attributes will not be. And then client writable will specify which attributes should be writable, and the remaining will be read-only. So it's like a good way of blanketly restricting, limiting access or constraining access to individual attributes. And then there's a facility for full-blown, full sort of fledged constraints, and that will let you pretty much shape your ORM graph every which way you like. So that's your ultimate pruning construct. Let me quickly show you what it looks like, and it's really not. It probably sounds more scarier than it is, but this is what it is. So this is in this particular case, we telling LinkRest that the only attributes we want included in this request are ID and attributes of the player class and one-to-many relationship to the visiting games. In those visiting games, we only want to include IDs and attributes and nothing else, no relationships. So if I were to go and request from the player endpoint both visiting and home games, I would get visiting games. Let's see. But I would not get home games because they've been constrained out of this API. So this is a handy way of managing constraints. Getting started is actually easier than it maybe looks. A lot of the code that you will see in this demo project, again, it will be available on GitHub, is boilerplate. It's straightforward, and it just you will see that it's just copy-paste type code. Substantive code is very minimal. This is a good starting point. LinkRest project is under it. This project is packaged with Boutique, which is another project that we've released, and it's now actually even not under NHL anymore. It's a terrific way of assembling and modularizing functionality that you kind of bring into a project. It's terrific. Check it out. The future is hopefully bright. That's why I'm here. I'm hoping that you guys will come up with some good ideas. I'm counting on feedback. I'm counting on your participation. Even if it's just, hey, wouldn't be nice to have this or to have that, and that's very valuable. We've been kind of living in a silo for a while, and this project works extremely well for us. But hopefully, wider audience will come up with better ideas. So with that, if you have questions. Not the last session, but close to last. So last day of the Sencha. Please.
So it's JAX-RS.
Yes.
It's returning a POJO, but you're able to only return certain fields in that POJO somehow?
Yes. Well, that happens before. So the constraining happens before that POJO, that object, gets into JAX-RS hands. So let me show you. So these constraints are fed to the LinkRest method, right? So the command chain. So LinkRest. outwardly bad. LinkRest knows about the constraints, knows about the data that it needs to process, and then it just it produces only the things that it's allowed to be produced, and that's obviously constrained by these mechanisms. So and it's only then that data comes to JAX-RS and is serialized out. So I don't know if, does that make sense? No? Okay. I'm kind of curious, who thinks of themselves as a full stack or otherwise is on like on the Java side of the fence of what we do here? Yeah, if you so maybe I went too far into Java. I tried not to, but I hope that. So tell your people you work with that this could be of help to you, and maybe that will make some good things happen for you. The way I kind of look at the benefit of this technology is, and I'm coming from the UI side, is that actually kind of makes you instantly a better developer. Not because of any new skills, it's just you get more available to you to play with in terms of building a better API. So you don't have to settle for just bells and whistles. You can substantively add to the context of any given scenario that you're working with in any given moment. So, and that's actually pretty powerful. The fact that you don't have to go through this math, please.
How does this compare to like using Spring Stack on the server side? Like, do you like compare and contrast?
Well, the Spring Stack is
the niche where this fits.
right. Spring Stack is, in my view, is kind of forces you into a certain way of doing things, and this really doesn't. So if in Spring Stack, you kind of end up having to shuttle in other technologies, and even if it's not forced, you kind of end up with a bigger bundle than you wanted to, and then you kind of you're on a path of getting forced into. I don't want to speak bad about Spring because it works extremely well for a lot of people. I mean, it's a great technology. But a lot of the time, at least in the world that we live in, really the thing that we care about is to be able to get our data in the shape exactly as we want it and be able to manage it and query it from the client on the initiative of the client, again, the way we want it. And we don't necessarily need to or want to think about adding new technologies that we would need to then maintain and support and worry about. Because this is a very narrowly focused, so the 3 technologies that we've released are very narrowly focused. They do what they do really well, and they don't force you to add anything else. So, and that may be something that works well for you, maybe not. Maybe you need more stuff, and that's fine. But this is how LinkRest works. That make sense? Spring is excellent technology. There's nothing against that. It's just different approaches, I guess, to how you integrate or how you implement these things. Okay. Well, thank you so much for coming. Again, thank you for coming.